In today's note, we're going to be looking at multiplying binomials. So binomials are basically two terms together. We can see examples here basically. So we have one term x and another term 3, and they're in brackets. So those two terms are multiplying another two terms. So we're going to look at how we can do that. And we're going to look at this in three different ways. The first way that we're going to look at, if we want to expand and then simplify, is we're going to look at using algebra tiles, which is kind of what we see over here. So the way the algebra tiles work is we have these large rectangles that are considered an x value. We have these small squares that are considered 1 values. So basically this is just a visual representation of what we see over here. And when we're asking to expand, what that is asking us to do, when we see expand, that just means multiply. And when we see simplify, simplify means we are collecting like terms. Or just making it shorter. So we're going to expand, or we're going to multiply these binomials. So when we use the algebra tiles, when we multiply them, you can think of it as kind of finding the area. So if I look at this large rectangle here, this one right here, if I want to find the area of that, that's just the length times the width. Or in this case, x times x. And when I multiply x by x, I get x squared. If I look at this rectangle here, this skinny one, we already see that it is represented by x. But if I wanted to find the area of it, if I do 1 times x, I get x. And then this one would be the same thing. And these vertical ones are the same thing as well. And then these small squares, 1 times 1, which just gives us 1. So once I multiply that, if I go through and I add up all these squares, so if I add up all of these, I get x squared plus 5x's plus 6. So I'm actually going to put that in red because that was my collecting like terms. So I expanded by multiplying, I collected like terms and got my answer of x squared plus 5x plus 6. We're going to look at doing it another way as well. And this is the way we would call the box method. So with the box method, what you would do is something similar. You would create a box, and because we're dealing with 4 terms in total, we're going to make 4 squares. On the top, we're going to put one of the brackets, so in this case, x and positive 3, and on the other side, we're going to do x and positive 2. And what we put on the inside of each box is similar to what we just did. We're going to multiply. So x times x gives me x squared, x times 3 gives me 3x, x times 2 gives me 2x, and 2 times 3 gives me 6. So when I do that, I will realize that I can collect some like terms, because if I add up all these inside squares, these two I can add together. I get x squared plus 5x plus 6. So I do get the exact same answer that I just found. And finally, the last method that we're going to learn is the FOIL method. So FOIL means first, outside, inside, and last. So basically what the FOIL method tells us is it tells us how we are to multiply these brackets. So if I go x plus 3 times x plus 2. So if I multiply my first two numbers, that means the x and the x. If I multiply my outside numbers, that's the x and the 2. If I multiply my inside numbers, that's the 3 and the x. And if I multiply the last numbers, that's the 3, and the 2. If I go through and I do all this multiplication, I get x squared from the x times the x, plus 2x from the 2 times the x, plus 3x from the 3 times the x, plus 6 from the 3 times 2. And then finally, at the end, when I collect my like terms, there's only two things that I can combine, which is the 2x and the 3x. And I get the same answer. So those are 3 different ways that we can get the same answer, or 3 different ways that we can expand our binomials. I'm going to go through B again, and I'm going to do the same thing. I'm going to show you the visual way of it, and I'm only going to show the box method. And then for C, I'm going to show you the visual way and the FOIL method. So you'll get more examples of each. Again, it doesn't matter which one you choose, just whichever one you're comfortable with. So for B, again, visually, we know the large rectangles are x, the small squares are 1. So we have x plus 1 and times x plus 5. When I go through and I multiply, I'm going to get a large square here, so that means x squared. I'm going to get a skinny rectangle, which is x. I'm going to get 5 skinny rectangles here, which are all x's. And I'm going to get a bunch of squares, which are all 1s. So if I go through and I add all these up, I have x squared plus 1, 2, 3, 4, 5, 6 x's, and then plus 5 1s, or plus 5. If I go through and do the box method, it's the same thing. I'm going to draw my box. Because it's 2 binomials, or 4 terms in general, I'm going to make 4 squares. I'm going to place one bracket on the top, x and 5, x and 1. And I'm going to do the same thing and multiply. So x times x is x squared, x times 5 is 5x, 1 times x is just x, or 1x, and 1 times 5 is 5. When I go to collect like terms, these two are the same, so I can add those together. So in the end, I get, x squared plus 6x plus 5. And we'll keep it color coded. So regardless of which way you choose to do it, you will still get the same answer in the end. If we try the next example, same thing. We're going to show you the visual method, and then I'm going to show you the FOIL method. So visually, again, we know we have x, then we have 1, 2, 3, 4. So that's our one bracket. And on the top, we have 2 x's, and then we just have 1. So that's our other bracket. When we go through and we make our boxes, or we make our multiplication, we get 2 large rectangles or squares. We get a rectangle. We get 4 rectangles down there, and we get another 4 over here. And then we get a bunch of small squares. So when we go through and add it up, we have an x squared, x, 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 another x. All the rectangles are x's, and then 4 1s at the end. If I were to go through and add all those up, I have 2 large x squareds plus 1, 2, so plus 9 x's, and then plus 4. If I was to do the FOIL method for this, again, remember FOIL is the first 2 numbers, then your last 2 numbers, then your inside numbers, and then your last numbers, and you're multiplying all of those together. So for the first numbers, 2x times x gives me 2x squared. 2x times 4 is 8x. 1 times x is 1x. And 1 times 4 is 4. If I go through, I can add only some of these up. I can only add up these 2 numbers here. So the 2x squared stays the same. 8x plus 1x is 9x, and then plus 4. So that's my final answer, and it's the same way when I do it visually. So every answer we have fits a certain pattern, and that pattern is an expression in the form ax squared plus bx plus c. And what this form is just basically, it's called a quadratic expression. So this is going to be our new type of expression that we're going to be learning about in this unit. So example number 2, we're going to go through and we're going to expand and simplify. I'm going to avoid going through and showing the visual way, but I will show the box and the FOIL method. So if I make my box for the box method, I put one bracket on top and I put the other bracket on the side, and on the inside I treat it like a multiplication table. X times x gives me x squared, 4 times x is 4x, 6x, and then 24. And once I've done that, I should see that there are 2 numbers that I can add up. If I've done this right, it should be these 2 diagonals always. Again, it doesn't matter which side you put your brackets on. I could have x plus 4 on the side and x plus 6 on the top. I would still get the same answer in the end. When I go through and add up all my numbers or terms, x squared plus 10x plus 24 is my answer. Now, if I treat that using the FOIL method, x plus 4 times x plus 6, FOIL again, first numbers, outside numbers, inside numbers, last numbers. If I do in this way, I should get x times x, which is x squared, plus 6x, plus 4x, plus 24. I can add up these 2 terms on the inside, similar with the box method. I get x squared plus 10x plus 24. So this is the same answer that I had already found. B, same idea. I'm going to go through and do the same thing. I'm going to create a box. I'm going to put one bracket on top, the other bracket on the side. Keep in mind here, because it is minus 4, I do need to include the negative. So 3x times x is 3x squared. 2 times x is 2x. Negative 4 times 3x is negative 12x. And negative 4 times 2 is negative 8. I can still add up these 2 side numbers. So I have 3x squared minus 10x, because the negative 12 and the positive 2, and then minus 8, which should be my answer. I can use the FOIL method as well. So 3x plus 2 times x minus 4. Again, first numbers multiply, then your outside numbers, your inside numbers, and then your last numbers. We get 3x squared minus 12x plus 2x minus 8. Similar to the last one, there are two things that I can combine, my 2x numbers. So I'm left with 3x squared minus 10x minus 8. Let me just move this down a little bit. Which is the same answer that I just found. C is a little different because we only see one binomial, but we should be seeing two. What we do want to recognize though is this squared. Right? The squared, remember, squared means something times itself. So in this case, this whole bracket times itself. So this actually works out to 4x minus 3 times 4x minus 3. So I'm going to do the box method first and create my box. I'm going to have 4x and then minus 3 on one side, and then 4x minus 3 on the other side. Just again, treating it the same way, multiplying. So I get 16x squared, negative 12x, negative 12x, and 9. From there, I should see that I can collect these terms because they do have the same variable. So I end up with 16x squared minus 24x plus 9. I'm going to do the same thing with the FOIL method and see if I get the exact same answer. So, I'm going to multiply my first numbers, then my last numbers, then my inside numbers, and then my last numbers. So we get 4x times 4x, so we get 16x squared, 4x minus times negative 3, so minus 12x, negative 3 times 4x, so minus 12x again, and negative 3 times negative 3, which is positive 9. Again, we do have some like terms that we can add together. So we get 16x squared minus 24x plus 9 as our final answer, which is the same as what we had previously gotten. So regardless of how you try to solve it, it is the same thing, whether you use FOIL method or the box method. In example 3, we're going to just look at a word problem using the same idea. The length of an HD TV is 2x minus 3 and the width is x plus 4. We want to write an expression for the area of the TV. Again, remember, if we're looking for area is equal to the length times the width. So in this case, I know the length and the width. They are just, it's just expressions, but I can still treat it the same way. So area equals 2x minus 3 times x plus 4. I want to expand and simplify this expression. So what I have to do, I have to multiply, because again, remember expand means multiply, and then collect any like terms, which is what simplify means. So I'm going to, again, I'll show you the two different ways to do it. The box method first, so 2x and negative 3 and x and 4. We get 2x squared minus 3x, 8x, and negative 12. When I collect all my like terms or simplify, 2x squared minus 5x minus 12. And if I were to do the FOIL method, 2x minus 3 times x plus 4, our first numbers multiply, our outside numbers, our inside numbers, And our last numbers, we get 2x squared plus 8x minus 3x and minus 12. There are two like terms that I can add up. Forgot to circle them back over here. And when I combine those like terms, I get a final answer of 2x squared minus, sorry, it should be plus 5x minus 12. So either way, again, you choose to do it, you still get the same answer. So that means that area is equal to 2x squared plus 5x minus 12. And we're told now that x equals 60 centimeters. So we want to know what is our area. So what this means is we have to sub this in. So we're going to sub in 60 for x and then solve. So area equals 2 times 60 squared plus 5 times 60 minus 12. When I go through and solve that, oh, 60 times 60 times 2 plus 5 times 60 and minus 12. 7,488. Let me just do it again to confirm. Yep. So our final answer is 7,488 centimeters squared because it is area. Now, even if you didn't get this simplified expression, you could still use the original equation. So area equals 2x minus 3 times x plus 4, and still substitute x in. So we would have 2 times 60 minus 3 times 60 plus 4. 120 minus 3 times 64. And you would get still the same answer. So this is just something to keep in mind if you are writing a test and you're not quite sure on how to find the simplified expression. You can still figure out what the area is when you have to substitute something in by using any equation that you're given. You could even take the x value and plug it back into the original diagram to figure out the length of each side and then multiply those two numbers. Either way would be fine. You'd still get the same answer. But again, the main thing here is just to remember how to multiply binomials. So you can do that again by either the box method, using a visual representation, or using the FOIL method.